Hey guys, what's up? How are you? So today's session I'm going to just discuss about the various problem that is based on the LTI system, nothing but linear time invariant system. Okay, we have already gone through the various conditions. Let us first recall the conditions for casual system, for continuous as well as discrete. When a system is said to be a causal system, a system is causal when I have already discussed the conditions for the causality system. Causal, it's clear from its name itself that a system is causal when its output depend on, if present output depend upon present input as well as past value of output but not on future, that's called causal system. So for continuous, if we have to find, then it is nothing but h of t is nothing but equals to 0 for t less than 0. Okay, if in case of discrete, it is of system response equals to 0 for n less than 0. Remember that. For stability check, for bounded input, bounded output, for continuous, that means minus infinity to infinity h of tau, we have d tau should be less than 0. For this, it is summation minus infinity to infinity h of n less than infinity. Okay, for static system, that is memoryless system, h of t equals to k of del of t, or static system, h of t equals to 0 for t not less than 0. For this, h1 of n equals to k into del of n, or h of n equals to 0 for n not less than. So these are the property for the causalities, statics and stability. So what is invertible system? Invertible system is what? If for two different input produce two different output, unique output, then it's called invertible. Otherwise, it's vertible system. Okay. So we have already gone through the various problem that is related to the invertible and non-invertible system. How we will know that this is a stable system, invertible and vertible system. We have already gone. Okay, now we have already discussed time invariant system. टाइम इवेंट सिस्टम है सिस्टम विच आर नॉट डिपेंड ऑन टाइम. ओके ना, टाइम इवेंट सिस्टम मतलब क्या? अगर इसका इनपुट करेक्टरिस्टिक डू नॉट चेंज विथ रिस्पेक्ट टू टाइम, दैट इज डिले इनपुट. डिले इन इनपुट is reflected in the delay in the output, that is called time invertible system. Okay, so delay in input reflected in the delay in output, that is called time delay system, that is called time invertible system. Otherwise, if output time, if in delay in input does not reflected in output, then it is called non invertible system. Okay, for causal system, a system with present output depend on present input as well as past value of output, not on future value, that's called causal system. Okay, that means value is on always less than 0. No problem. Okay, so for stability system, we have already discussed that for bounded input, the output should be bonded. For invertible system, if two different input, different amplitude leads to different output, then it is called invertible system. Okay, now I will discuss some of the problem based on the LTI system along with some of the properties, left properties of this. Now before solving problem, Let us give some of the clue, some basic concept. Okay, now see h of t convolution with x of t is what? Is nothing but y of t. Okay, x of t, h of t is convolution, x of t is nothing but y of t, and y of t is nothing but integration from minus infinity to infinity x of tau into h of t minus tau into d tau. It can be written also as a minus infinity to infinity x of t minus tau into h of tau. Okay, no problem. That means this is our system. That means if this is the system, we are giving the input as x of t and we are getting the output as a y of t. It system response of h of t. Okay. Now if we give this input as impulse signal delta of t, then output is what? Output is nothing but h of t. That is okay. H of t. Hana. This is, but for the stability criteria, but this is what h of t. But for a stability criteria, for a stable system, a system to be stable, it should be follow bounded input, bounded output. Bounded input and bounded output. That means if we give the bounded input in this system, if we give in the system bounded input, then we should get a bounded output. That means what? That means nothing but, that means x of t minus tau into h of tau d tau is nothing but, it should be finite. Finite of h of tau. इसका यही मतलब है ना, it should be finite only. finite होनी चाहिए. It should be finite. Okay. That means what? If in this condition, if we get y of t as, if we get as y of t as 5x of tau, x of t, then h of t is what? Is nothing but, if we yt equals to 5x of t and if we take x of t is delta, then it is nothing but 5 delta. It is finite. But if we give this system as 5 del of tau, then it is infinite na. If it is given to this system, है ना, yt में अगर हमने दिया yt equals to 5x of t है, that means del of t है ना, ये मतलब यहाँ गया, यहाँ इसका मतलब 5 दी हम, ये del of t है. या हम बोल सकते हैं कि del of t हमने यहाँ दिया, ये 5 सिस्टम में, 5 of x of t है. That means here 5 of x of t है, where x of t is nothing but equals to del of tau. So it is equals to 5 del of tau. एक चीज़ देखिए कि अगर इफ़ वी हैव a system, if we have this system, we are giving x of t as an input, we are getting y of t as an output. Output is nothing but h of t. It is nothing but, you can say that this is system. Again we are giving that h of t, it is x of t. Okay, so again we just give to another system. This is for condition for balance input, balance output. If we give the x of t, then we are getting here as x of t convolution with h of t. Now again, if we take h inverse of t, that means then again it will be what? Again it will be x of t convolutions with h of t. Okay, convolution with h in v of t. That is nothing but x of t will be what? X of t will be what? X of t into del of t. Okay. Take del of t. Why? Because it's h of t into del of h inverse of t, nothing but del of t. Okay. So take invertible system. Now टेक वन क्वेश्चन. अगर यहाँ पे हमने एक्स ऑफ टी दिया है सिस्टम में, वाई ऑफ टी मिला, अगर इसको हम फिर इन्वर्स कर दें इन्वर्ट, तो हमें क्या मिलेगा? एच ऑफ टी इंटू एस ऑफ टी. ये क्या मिल जाएगा? एक्चुअली में एक्स ऑफ टी ही बचेगा. ये हमारा डेल ऑफ टी हो जाएगा. डेल ऑफ टी इंटू एक्स ऑफ टी इज नॉट वन थिंग, ओनली एक्स ऑफ टी इंटू टी. यहाँ चला जाएगा एक्स ऑफ टी इंटू डेल ऑफ टी. हाँ, देखते हैं क्वेश्चन. इफ़ वाई ऑफ एन इज गिवन एज एक्सपोनेंशियल दिस वन, so how we will know that this is an unstable system? So we will have to analyze whether linear, stable or not. So e of f to the n, that means it is like somewhat this. So it is let me see. Let's put for stability check. For stability check, put u of n or u of n. Okay, so y of n is equals to exponential u of n. That means this is nothing but u of n. And exponential of this is what? Exponential of finite term is what? Hey guys, see, if it is exponentially final, that means it is a finite value. So it is always, will get finite only, because if we take exponential to the power 1, that means only 2.71. Approximately it's finite only, na? Finite value will get. So always get finite value. That means it is a stable system. But it is exponential, so it is non-linear in nature. So it is exponential. We have to take stability for linearity check. Let us see. N plus exponential u2 of n Okay, this is for y1, this is for y2, then exponential u of n u1 of k, that means is not equals to exponential u of n u1 into this is not equals to this one because this base is same, that means exponential u1 into it is like this one. So this is not table, so this is non-linear because superposition principle, or we can say that superposition not follow, so it is non-linear. It is what? Non-linear in nature. Okay, we have already gone. Okay, hey guys, see, previously we have taken u of exponential to the power u of n, so it is stable system, we have already seen, because its value is 3.7 approx. If we take h of n is equals to exponential del of n, let us suppose this, take this, if we take h of minus 1, then exponential minus 1 is what? 0, it is nothing but 1. H of 0 is nothing but exponential 0, it is nothing but exponential 1, mainly del of 1, and we know that 1 is nothing but delta at delta of 1. Okay, so now see, at exponential 1 is what? Exponential values. Okay, now if I take h1, it is exponential 0, so it is 1. So what we find that if we take summation from minus infinity to infinity h of n, it is nothing but from 1 plus 1 plus exponential plus 1, it is so on. It is up to infinity actually on a stable system. It is up to infinity. Okay, so we can say that impulse response is strictly valid for LTI system. Okay, because exponential x1 of n is non-linear. Okay, it is not LTI system. Okay, so for which we have to because strictly LTI system, because impulse response here it is in infinity, so it is an unstable system. Okay, now see next question, if h of t equals to, we take exponential minus 3t into u of t plus 2, that means it is somewhat like this, exponential minus 3t, it is 1, and u of t plus 2 is somewhat here. So it is nothing but sorry, it is here. It is here because it's t equals to minus 2. So this signal is there and this signal is this. It is two-sided signal. So it is what? It is non-causal type of signal, okay? Now for checking stability, we have to integrate this one from minus infinity to infinity, exponential minus 3t k dt, and that's value will be what? That will be from minus minus 2 to t dt only. So it is nothing but exponential minus 3t by minus 3, that is nothing but t by minus 2. So it is, see here, it is exponential minus 3t. We take minus 3 as common, so we will get exponential minus 3 into 2. We'll get this one, that is nothing but exponential minus 6 minus exponential minus 3t by 3, that is finite. Its value is finite, so it is stable system. It is a stable system. It is causal system, a stable system. Okay. If we want to check this linearity, then what we have to do? We have to follow the principle of superposition as well as principle of homogeneity. Okay, principle of homogeneity. Now see, let us check.